What do we want this place to be like? This great Pacific Northwest. With endless concerns about global warming, toxic chemicals in our troubled waters, and the bottomless supply of garbage we'd like to ignore, is there any hope this precious area will remain precious for the next generation? For the past century, the University of Washington has been making great strides in finding solutions for a sustainable world. It's in our nature, our DNA.
When you think about universities, per square inch, we have more brain power out there with our students and faculty than probably any other place in the world.
Will that brain power help shape our future? How can the UW carry on its commitment to sustainability for the next 100 years?
Our kids were among the very first in the nation to protest putting garbage into landfills. We've been doing research on the environment for about as long as anybody can remember. So the commitment has been pretty deep, pretty abiding.
Journey with us as we explore the innovative research and development that exemplifies the University of Washington's commitment to the future.
This is the side of the volcano right here, so that's...
We learn about cutting-edge research being done by UW scientists at the bottom of the sea. We discover how UW researchers are working on a system that can turn fog into water. Could it potentially save a low-income community that gets less than an inch of rain per year? And how can tidal currents in the ocean provide us with a new source of renewable energy?
The University of Washington research that comes out of this project is going to be just absolutely world-leading. We're going to learn things that no one else in the world has ever been able to learn.
All of these stories now on Climate of Change.
So this is Ravenna Park.
In 2012, Justin Hellier graduated from the University of Washington with a master's degree in public administration. While he was a student, he helped establish the Campus Sustainability Fund, a student-initiated program that supports a cornucopia of sustainable projects on campus.
And we just really saw a need for that, and we also saw a will among students.
Today, Justin is sharing what he learned at the UW with the world at large. He's working for EarthCorps, a nonprofit conservation group based in Seattle that specializes in ecological restoration. One of their most recent projects, the restoration of Ravenna Park, a park rife with invasive plants.
So about 100 years ago, when Europeans first colonized the area, the first thing they did, of course, was cut down all the trees. And they also introduced a whole bunch of invasive plants, so plants that came from somewhere else and don't really get along with the ecosystems here. One of them is this guy, English ivy.
As it turns out, English ivy is a colonizing vine that can take over a forest and prevent younger trees from developing. That's what's happened in Ravenna Park.
And what we've done here is to remove those invasive plants, right? And on this steep hillside, it's no small feat, but to dig them out root by root and to replant native species, especially trees. Really trying to reset the ecological trajectory of the site, to put it on a more sustainable path. And so that's what we've been up to here.
It's the type of action that the University of Washington wants to see from its graduates.
The thing that I learned really from my time at the university was that our biggest impact, whatever organization we're in, is not how much water we're using, how much energy we're saving. Those are really important, those are critical, but the biggest impact is the impact we're having on the people. But most of the work we need to do is on building up human beings' understanding, people and communities' ability to understand and act on critical environmental issues.
Katie Stoltz was also one of the founding members of the Campus Sustainability Fund. She too graduated in 2012 and is now working for Washington Bus, a statewide, nonpartisan, nonprofit organization that encourages young people to get involved in politics and civic life.
a lot of those decisions and a lot of sort of the voting participation is going to be coming from young people. So excited about your show tonight?
Oh, definitely.
When it comes to sustainability, getting the right people in office, educating voters about the choices they have, has everything to do with a commitment to the future.
And so even if we're not involved directly in either working for an environmental organization or something that's specifically related to environmental politics, we're doing something that's involved with influencing essentially our fellow peers in the process.
Katie says her education at the UW has more than prepared her for this kind of work.
It was my initial passion, initial sort of wanting to work on environmental sustainability at the University of Washington that got me where I am today.
Katie believes if the UW continues to instill that motivation into its students, the future looks good for everyone.
I mean, students from the minute that they get in, if they live in a residence hall on campus now, they see composting in the residence hall, they see the recycling is sort of a huge component of it. They just see it alive on campus, which is something that I think is a unique component of at the University of Washington. It's why we've been rated first in the entire country. It's why it is a commitment for the university, but I think it's also because students are understanding why it's important and they're understanding sort of the long-term impact of it.
They are well aware that they are the inheritors of the planet.
University of Washington President Michael Young is pleased to hear stories about graduates who are using their education to preserve the planet. But he knows being committed to the future means more than preparing students for the real world. It involves expanding research and finding new solutions to the pressing problems surrounding climate change and carbon reduction.
I think the university will continue to work hard and grow in these dimensions. I mean, one of the things that I've encouraged everybody to think about is the university as both internal research laboratory and external clinical trial. So in other words, if you have some ideas about solar power, about imaginative ways of recycling, energy conservation, let's try it out here. Let's experiment. Some will work, some won't work. Not only should the university be a place that develops these great ideas, but let's try them out.
At the University of Washington, the great ideas are being tried out on land, in the air, and at the bottom of the sea. A science team from the UW School of Oceanography boards a research vessel to embark on a most unusual mission. The team is part of the Visions 11 science expedition that will explore experimental sites in the Northeast Pacific Ocean.
If your family decided to build a spaceship to leave Earth and go to another solar system, you would never leave Earth unless and until you fully understood the life support system. Why is the global ocean important? Because it's, plainly and simply, it's the life support system of the entire planet.
On this leg of a 3-week expedition, their destination is Axial Seamount.
This is the side of the volcano right here, so that's right there.
An active and unpredictable undersea volcano, more than a mile below the surface.
Axial Seamount, about a 5,000-foot tall mountain on the seafloor.
Dr. Deborah Kelly has been here before, but this cruise is different because Axial Seamount has recently erupted.
Well, this particular volcano erupted about 3.5 months ago, and it's very exciting to us to be able to see, shortly after that took place, what the changes are.
On land, when a volcano erupts, it often captures the imagination of the world. In the ocean, only a few people, like Dr. John Delaney, know eruptions ever occur.
It's quite a challenge, you can imagine, understanding a biosphere that no one ever sees because humans don't survive well underwater, particularly 2 miles down.
So you think that that erupted?
But John Delaney wants to change all that. The primary goal of this voyage is to establish a system of undersea scientific outposts connected to the internet.
To function on the seafloor as if we were there is to have a permanent presence in the ocean via a new technology, and that's fiber optic communications technology.
Typically, fiber optic cables crisscross the sea floor and carry massive amounts of data from one continent to the other. But here, UW scientists will wire experimental sites like Axial with cables and instruments to generate non-stop information about the ocean. It's called a Cabled Ocean Observatory, and the project at Axial Volcano is part of a 5.5-year effort to install the system in the most dynamic areas of the deep sea. First envisioned by Delaney in the 1990s and developed over the past 20 years, the Cabled Observatory is part of the Ocean Observatories Initiative, or OOI, sponsored by the National Science Foundation.
At the other end of these cables, we're going to have robots, we're going to have sensors, we're going to have instruments, we're going to have entire laboratories set up where people could actually have live video or information from the sea floor. And so when events take place, we could actually be there without being there.
So when the Axial Volcano erupts again, everyone on land who wants to watch it will be able to do so in real time.
And it's not surprising that humans who have only been on the planet for a very short period of time and all live on the continents don't understand the ocean. That's what oceanographers are about, is trying to understand at a very fundamental level that is also very useful, societally useful, how the ocean works. Now we can put thousands of sensors in touch continuously with the ocean environment. We literally have new eyes.
The Ocean Observatories Initiative will provide the public with unprecedented access to the ocean. Scientists hope this information will lead to substantial discoveries that could help preserve the way we live on land.
If the oceans don't work well, the human race suffers. We're delicately balanced on the edge of what might be a series of oceanic changes that we don't understand. And if we don't understand them, and we have an ever-growing population, 40 years from now, there's going to be 9 billion people. That's bad news, because the oceans drive everything.
As John Delaney and his team continue to explore the secrets of undersea volcanoes,
And you can see the rotor spins as such.
another team from the University of Washington is participating in a different type of deep-sea exploration.
The way this generates power is you have the flow moving through the turbine rotor.
Since 2009, Brian Polaggi and a team from the UW's Mechanical Engineering Department have been studying the possibilities of turning tidal currents in the ocean into renewable energy.
Easiest way to think about tidal power in the way that I think about it is like an underwater windmill. And the idea being that much in the same way as wind turbines, when they're exposed to a very strong wind, will spin and generate power, in locations where you have very strong, intense tidal currents, that same thing can happen underwater. So this is an image of an actual tidal turbine rotating, generating power. You have, some sort of a support structure, turbine, probably 3-bladed, a generator, a power cable that goes back to shore. I mean, all of them have the same components. Turning rotor, water flows, rotor turns, power is generated.
Such systems already exist on the East Coast and in Europe.
I'd like to start the source at 9:30.
Brian Polaggi wants to help put one in the Pacific Northwest, near Port Townsend.
We are working with a number of developers that have projects going on the East Coast and the West Coast. We're particularly involved in a project up in Northern Admiralty Inlet. It's a demonstration project led by a local utility, Snohomish County Public Utility District. That's one of our Sea Spider platforms there.
It may take another couple of years for the demonstration project to get off the ground and into the water. Before you can place turbines underwater, you must understand what the environmental conditions are like. Where are the best currents? What impact will the rotors have on marine life?
And the tool that we developed to look at this is something called a Sea Spider tripod.
As it's lowered underwater, the Sea Spider surveys tidal currents and conditions. It has cameras and hydrophones that collect important data that is relayed back to shore. It's data that will eventually be shared with tidal power developers around the world.
But the oceans are a tremendous source of renewable power. And so the reason the university is involved is because this is relatively early days in a renewable energy. Not very much is known about it from the standpoint of the technology, the environmental effects, or the societal impact. And that's where university researchers have a great role to play in this, in trying to really design what I would call truly sustainable marine energy systems.
Brian says it's possible that someday in the near future, remote communities in Alaska and other areas that have access to fast-flowing tidal currents could see this sort of technology generate power.
The University of Washington research that comes out of this project is going to be just absolutely world-leading in what we learn in terms of how marine animals interact with devices, the effects of sound, the artificial reef effects. We're going to learn things that no one else in the world has ever been able to learn. And that's, to us, very exciting, and that's a great reason to be at the University of Washington doing this type of work.
Uncovering new sources of renewable power, finding innovative ways to be sustainable. The UW is discovering solutions in the ocean, on land, even in the air. They call it the Hoop House, a little nondescript white plastic hut on the University of Washington campus. Inside, you'll find a dripping mass of fog that's full of very good intentions.
You ready?
We can scale anything up to per unit time and per unit area.
With a grant from the U.S. Environmental Protection Agency, researchers at the UW Biology Department are experimenting with a variety of low-cost nets that capture moisture from fog. The team is manufacturing fog with a machine, trapping moisture from the fog with nets, and then converting the moisture into flowing water. Professors Susan Bolton and Ben Spencer became interested in developing this technology when they visited a low-income community on the outskirts of Lima, Peru. Water is scarce there. With just half an inch of rain a year, the area has few trees and very little other vegetation. And the neighborhood isn't connected to Lima's municipal water system.
Right now, they're running largely on water that comes from the Andes, from the glaciers that feed the rivers that run through the city that the city has relied on for years. Sooner or later, the glaciers are going to be gone because they're melting very quickly. The tropical glaciers are some of the ones that are melting the fastest in the world.
They're losing water supply, their population is growing, they don't have any local water resources available, except that the city is covered with fog for 8 months out of the year.
That could make a huge difference. Lima's fog, combined with its location near the coast, is ideal for making water. If large-scale nets could be put up to capture moisture from fog, it could greatly improve life there.
You really have to have a major body of water and the wind pushing the fog up into the hills. Moving fog is the key component to being able to harvest it. It has to be blowing through the fog collector in order for it to accumulate. It can't be stagnant.
Collecting fog effectively is essential. At the UW, it's a multidisciplinary effort, with team members coming from engineering, architecture, environmental and forest sciences, and landscape architecture.
So we're thinking about how the fog collection is subsequently stored, how it's then used to irrigate vegetation and used subsequently for household use. So we're using fog and the fog collectors to irrigate trees, which in turn can become fog collectors themselves, and then we can collect that drip from the trees in these public spaces for other uses.
Tapping resources from unconventional places. At the University of Washington, it is happening everywhere, even in old familiar places.
I think this building embodies many of the ideas that we're trying to do in our future buildings, and we're doing it right here.
John Lebo works for the Capital Projects Office, the group that designs, manages, and constructs all of the UW's buildings, including the newly renovated Hub. From the very beginning, the Hub was reconstructed with sustainability in mind.
We recycled all of the materials that we possibly could from the building, asphalt, concrete. The other thing that we were very conscious about was the reduction of energy. So most of this building, in fact, is naturally ventilated.
Operable windows open and close automatically, to maintain the ideal temperature inside. In the Lyceum room, an impressive array of towering wood panels swing open with the flip of a switch.
Those large wood panels we think of sort of as flaps on a wing, where they open and close to help control the light that enters the building, as well as shading those spaces.
Down in the basement, things get really interesting.
This is the heart of the heating system for the hub.
It's a heating system that remarkably runs on the wasted heat that radiates from refrigerators, heaters, and coolers all over campus. A water source heat pump captures wasted heat and converts it into usable energy to heat water and air in other parts of the building.
So it's an amazing thing because we're using really the waste heat from all over campus and from the building to heat this building. It's really almost, you can think about it as free heat. Actually, this is very uncommon.
But it's being done right here at the newly renovated hub.
I think this is a really great example of what we're trying to do across campus, and you'll see many of the features that we have today in this building being done in other buildings in the future. Each time we build a building, we're looking for new ways to make the buildings more efficient, better for the people that work in these buildings.
Looking for new ways to be more efficient. It's been going on at the University of Washington for the past century. Along the road, the UW has developed several partnerships with government agencies and businesses. One of those partnerships has been with Seattle City Light.
University of Washington's been our largest customer for years and years.
Saphir Hamilton, Chief of Staff at Seattle City Light, says the partnership with the UW has evolved in many ways.
Whereas University of Washington has been recognized nationally as one of the most greenest campuses in the country, we think of ourselves as one of the greenest utilities in the country, and it just makes sense that we'd be working together to find new and innovative ways to save energy together and make sure that we're sustainable into the future.
One of the innovations has been the implementation of a wide-ranging incentive program. During the past 20 years, Seattle City Light has given $11 million in incentive payments to the UW to help upgrade some of its facilities with LED lighting, energy-efficient windows, and advanced air conditioning and heating systems. The results?
Almost $5 million a year of cost savings to the university. So every year, the University of Washington is saving almost $5 million as a result of the partnership with Seattle City Light. So whether you're at the gym or your dorm or academic buildings, guarantee Seattle City Light is helping in partnership to upgrade that lighting to improve the heating and cooling system and the building envelope.
But Saphir Hamilton is quick to point out that the partnership between Seattle City Light and the University of Washington is a two-way street.
And they're helping us. The University of Washington comes up with new innovative ideas for how to save energy, and working with our energy advisors and at Seattle City Light are able to push the envelope and say, hey, maybe we haven't thought of doing it just that way, but all the great minds on campus thinking of new ways to save energy, really in that partnership. It's not just City Light telling University of Washington, here's what you should do. It's really having a dialogue and good ideas flowing both ways.
It excites me that we are so committed to this.
Viella Warren, Senior Vice President of the University of Washington, says when it comes to sustainability, the UW has always taken the proverbial bull by its horns.
We are a huge mini city, if you will, inside the walls of Seattle, and we have all of the water and energy issues that any little city has. When we layer sustainability onto that, it could either, I suppose, lead us to go home and give up in despair, but instead, because we are the kind of people that we are, because we have young people with passion, because we have faculty members who just don't give up. If they can't buy a machine they need for their research, they make it.
This is one of our projects that is going to be
It is
built
that
soon.
sort of commitment that gives hope that the University of Washington will continue to be a major player, a world leader, when it comes to finding solutions for the myriad of environmental issues we face today.
If we can use our physical plant to help our faculty and our students think about this in ways that will allow them to make breakthroughs, that would be great. And of course, at the same time, we're solving the university's problem. We have to figure out ways to be more sustainable. We've already made great strides.
The University of Washington has made great strides, and it will continue to do so with a passionate commitment to the future. A special atmosphere has taken root here, one that dares to be curious, one that embraces the challenges that lie ahead. In this climate of change, many uncertainties loom over the horizon, but one thing remains constant. The University of Washington will continue to find solutions to our rising environmental problems as it points the way to a better, more sustainable world. I'm Carolyn Douglas.